So, seamless teleportation. It's a mechanic that's been used a lot in games like the Stanley Parable. The Doom My House WAD used it to great effect as well. It's a really great way to kind of trip your player out and make sort of impossible rooms that don't make any sort of sense. And I'll give you an example of what it looks like real quick. If I walk into this little hallway here and turn the corner, you'll see that I am suddenly right back where we started on the opposite side. Um, and there's no smoke and mirrors going on here. It's the same little hallway going off into nowhere. But as soon as you go through, you're actually just being teleported to the other side, where you come out a pretty much identical tunnel back to the start. So let's see how you can make this. All right, so here we are working in Unreal Engine version 5.7 using the default first-person template. And nothing we're really going to be doing in this tutorial is all that difficult. The code is relatively straightforward, but the trick in this effect isn't in how you program it, it's really in how you design it. You got to be really particular in how you're making your level, because the entrance and the exit for your teleport need to match each other exactly. Even the smallest change in lighting or texture is going to be noticeable. And, then your player's immersion will be broken immediately. They'll refund your game, leave a bad Steam review, and then your career as a game dev will just be over. So as beautiful as lumen lighting looks, asking it to be consistent for a microsecond teleport is just a bridge too far for Epic right now. Instead, I'm just going to go ahead and disable it entirely and use static baked lighting. So if you don't know how to do that, you go into your project settings, you type in lumen. We're going to set dynamic global illumination method to none and our reflection method to none. I'm going to type in static. And under here, we're under misc lighting, allow static lighting. I'm going to leave that ticked. And it's going to say that a restart is required, so go ahead and restart.
1 eternity later.
Wow, okay, that took a long time. All right, close this down. Now we need to, in our world settings, make sure that force no pre-computed lighting is checked off. But if you are using the default starter map, like I am, the one that comes with the first person template, for whatever reason, another hoop you're going to have to jump through is this level has it hard coded into it for some reason that you cannot have force no pre-computed lighting off. So if I reload the level, you see it just turns itself back on, and it's never really off. So I'm going to make a new level here. Call it level underscore test. Open that up. Or sorry, I'm going to first go back into our first person level and copy and paste everything except for my world data layers and world partition minimap. Copy those. And then we can just paste them over in this level here. Almost there. We're going to go ahead and change our lighting condition here a little bit. Build lighting. Okay, I just moved the directional light a bit more and rebaked a couple times. That's all the setup we really should need to do for our scene here. Next little caveat is if your first-person character is using a spring arm with camera lag enabled to sort of interpolate your camera movements, that will unfortunately not work. You'll need to disable any sort of camera lag for this to work. Otherwise, it's going to show your teleport. But if you're not using that, you don't need to worry about it. So that's it. That's the only two caveats we really had. We can get started now. After jumping through all those hoops. I'm going to right click, create a new blueprint class. of type actor. Call this BP underscore seamless teleport box. Double click to open that up. And we're going to need a couple of components here. So I'm going to make a box collision and name that entrance. And then I'm going to add an arrow component to that. That's called entrance forward. Now I can copy and paste that box, rename it to exit, and same with the arrow as exit forward. Now we have two independent boxes that are both attached to the default scene route, not to each other, and they each have a forward arrow pointing the same direction here. But I want to make sure that they can't be a different size. So I'm going to come into my construction script here, and I'm going to make a new variable called box size of type vector. Compile, and I'm going to give that a default value of 30 in all of the fields. And then I'm also going to make it instance editable and exposed on spawn. So if I drag out my entrance and my exit and our box size variable, and then our entrance, I can type in set box extent. I can actually hook up exit into that same target node, and then use our box size as our extent on our construction script. Now, whenever I change that box size and compile, it'll change our box, both our boxes. So they're always the same consistent size. And you'll see why that matters soon. Now, in our event graph, I can delete all three of these because we don't need them. And we come into our entrance. The only event we're actually going to need in this whole blueprint is on component begin overlap. Right when we overlap our entrance box, I'm going to check that the other actor equals our get player character. And then I'm going to hook that into a branch. I make my branches again by holding down B and left clicking. Hook that in there. And now we're going to need to do this in 3 parts. I'm going to do each part one at a time, and so you can see why they're necessary. First, we're going to get the player's transform, and then make it relative to our entrance box, convert that over to our exit box, and then convert it into world again. So how that's going to look is we're going to make a new function, call it get destination transform, and we're going to get our player character, get actor transform, so we get the actor's world transform, and then we'll get our entrance and get its world transform. Now we can just use a handy node called make relative transform, plug get player character into A, and then we can make it relative to our entrance. So now we need to make it relative to our exit. So we're going to get our exit, get its world transform, and we're going to use a node called compose transforms, essentially combining them. Then we can just get a return node, hook in our transform into the return value, and I'm also going to check pure, so that in our event graph, when we want to use this function, we don't need to hook up an executor to it. It's just a reference. Now we can get our player character again. And set actor transform to be our new transform. Now we can go ahead and test this. I'm going to come out into our level and drag in our seamless teleport box. Positioning does matter quite a bit. You want to make sure that, the details obviously match. So I'm going to drag it in here, rotate it around so that our arrow is facing forward. We're going to enter in this way and exit out that way. Make sure it's in the center of the room. And I'm going to change my box size here to be something like, let's see, 50? Yeah. 30 works for that. 200, 200 for the other two. So it takes up the whole entire hallway. You can't miss it. Then in my details here, I'm going to scroll down under our blueprint and select my exit reference so that we can edit it independent of our entrance. And I'm going to drag it where I want it in my other hallway here. Let me double check the spacing on that. We were 1, 2, 3, 4 lines away. 1, 2, 3, 4 over here. In the center of the room. Now we're all lined up. Let's give it a test. So we walk into our entrance here. And we get teleported, but you can see we're facing the wrong wall. We should be facing forward. So what's going on here is we're not actually changing our rotation with that transform. We're changing our object's rotation, but we're not changing our control rotation, which is what handles our camera here. So we need to update that as well. Back in our blueprint, we're going to make another new function. This one's going to be called get control rotation. And inside of here, we're going to get our player controller this time. Get control rotation from that. It'll be a rotator. And we can use that to get the forward vector of that rotation. And we're going to use a node called unrotate vector, which takes in a rotation. So we're going to get our entrance and get its world rotation. So we unrotate our player's control rotation by our entrance's world rotation. Then we can drag that rotate vector, into a rotate vector. And predictably, we're going to use our exit's world location to rotate that vector around. We can hook that into a return node as well and make it pure. Or sorry, we can make rot from X. Sorry, that first. Then plug that into the return node so that we get our rotation. Make it pure. We can drag it out. And then we'll get our player controller again. And immediately after we set our actor transform, we're going to set control rotation. Plug that in. Compile, save, and let's test again. We can walk into our box, and it looks pretty good. You can tell there's definitely a change in the lighting there, but there is also a noticeable little bump where we're moving kind of to the side a bit. And what's going on there is our velocity is not changing at all. So we are still moving forward in this direction when we go through the teleport box. So we'll end up going a little bit closer to this wall. So we need to make sure that we're also changing our velocity to be rotated the same way that our rotation or our transform is, or our control rotation. So let's go back into our blueprint. Make another new function. We're going to call this get destination velocity. And we're going to get our player character. From our player character, we can get its movement component, because every character has a movement component. And then we can get the velocity. And unrotate this vector again, using the rotation of our entrance. Get world rotation. And we can just rotate that the same way we did for our control rotation. Rotate vector around our exit. Rotation. Hook that into a return node again. Make it pure. And that is the last step that we should need to do to make our teleport seamless. We just need to get our player character and get our movement component. And then set velocity to be our get destination velocity. Compile and save. And let's test it out. We walk forward. You can definitely tell with the lighting change, but it is pretty much unnoticeable. There's no bump or anything. We're moving consistently in the same direction. And then one more thing that's really going to help our scene here is dragging out a post-process volume from our place actors panel and typing in infinite extent to make it unbound, and change the exposure type from auto exposure histogram to manual, and then change that exposure just manually and keep it at a consistent level. Now when we play test, it's going to look pretty flawless. Pretty good. And that's about it. Thank you guys for watching. Hope you enjoyed. Leave a comment if you want to see another tutorial. And thank you.